All right, now that we've discussed work and, worked with it a little bit, it's time to start taking this a little conceptually and introducing a new concept that's very closely related to work. So, think about this question: which is more work, walking up a flight of stairs or running up a flight of stairs? Okay? And similarly, or maybe differently, which case do you end up being more tired? So let's think about that. Odds are, running up a flight of stairs versus just walking slowly up one makes you more tired. But does it actually make you do more work? So let's fill out this chart kind of thinking about these two situations. All right, so if we're just going to focus on the vertical force, all right, and say in both of these situations we are moving up at a constant speed. All right, so if we draw a force diagram for both of these, where there's going to be the force of gravity going up, and then your applied force is going to be in the upwards direction, getting you up the stairs. And if it's at a constant speed, what do we know about those two forces? Your applied force is equal to your force of gravity. All right. Does moving up the stairs at a faster constant speed affect this relationship at all? Hopefully you are saying not. So the vertical force required is going to be equal to Fg, so it'd be Fg for both. All right. Think about the distance that would be traveled. It's the same flight of stairs, and since we're just going to focus on vertical things, it's going to be the vertical distance or the height. Does moving up a flight of stairs faster affect the height of the flight of stairs? Hopefully you said no. All right. And then the last thing to look at is time. All right. So walking up a flight of stairs, this is the one place where we do see a difference. It takes more time to walk than it does to run. All right. Now, think about this though. What is our equation for work? Work is equal to force times distance. Is time in there at all? Hopefully you are saying no, and recognizing that time, the speed at which you do something, has absolutely no effect on the amount of work done. What does change based on the time it takes to do your work is your power. All right, so power is the rate at which work is done, or how quickly work is completed. All right, so to find the power to do something, you take the work, or FD, and divide it by the time that it takes. Okay, and we'll talk a little bit more about this, but work is very closely tied to energy, so it could be the amount of energy used divided by the time, and that would help you solve for power as well. Okay, so based on that, our units for power are going to come from work divided by time, or joules divided by seconds, which is also known as a watt. Okay? So the only difference between walking and running up a flight of stairs is the power it takes. All right? The change in, and again, we still need to talk about this a little bit, but eventually we will talk about potential energy. But the change in work, or potential energy, going up a flight of stairs is the exact same. All right? But when you divide by time to get power, then that changes. All right? Now, think about this conceptually one more. What increases the amount of power needed? Running or walking? You gotta think, you're dividing by time, so it's going to be an inverse relationship. So more time equals less power. And that's why when you walk up a flight of stairs, it is easier to do than it is to run up the flight of stairs, or you get less tired because you're expending less power. Another way to look at power is in terms of velocity. All right. So sometimes you may have a change in velocity going on. In order to calculate power, you need to find the average velocity over which the work is done. All All right, and that comes from the fact that if instead of writing that power is equal to work over time, if we split that up into FD over T, hopefully you recognize distance divided by time is velocity. So you could be given a car engine applies a force of 500 newtons when the car goes at 35 meters per second, and then you could find the power then. All right? So just a quick sample, easy level 1 type problem you should be able to do. How much power is needed to move an object with a force of 100 newtons across a 4-meter table in 5 seconds? All right, so we have 100 newtons this way, the distance is 4 meters, and time is 5 seconds. So based on that, we know that power is work divided by time, or FD divided by time. So we're going to have power being equal to 100 times 4 divided by 5, or 80, and hopefully you are saying joules divided by seconds, or watts. Okay, make sure you remember to fill out the online form that is following this video and have it ready. Bring some notes to class so we can work on problems and do activities. See you in class.